Sorry guys, as I was telling you, we are just going to take off as if we are in an ISA environment from an aerodrome that is 1,319 feet um, of altitude, okay? And this is about density altitude. It's once again, it's not mandatory. It's just nice to know how your aircraft is going to behave with the current temperature conditions. All right, and with this said, let's go back to the graphs. So now you know that in let me put this beside here. You know that your rate of climb during takeoff it's going to be something like 630 feet per minute as it is here, and your takeoff during cruise, assuming that you're going to fly near 2,000 feet, it's going to be around 500 feet per minute. All right, you have it here also. And with this said, we can go further into cruise. We have, if you wanna, if you're doing a navigation or something, and if you want to know time, fuel, and distance to climb, you can also use this chart. Okay, I'm not gonna do that today, so we're just going straight to cruise performance, and this is basically where, as you know, you manage your cruise. Either you want to go fast and uh, consume a lot of fuel, or you want to go slower and consume less fuel. Also called as cost index, I think. So um, yeah, so I chose 2,000 feet for my cruise flight and 2,200 RPM, and basically I put it here. So cruise, so 2,000 RPM, 2,000 feet, 2,200 RPM. It will give me 90 knots, 4.6 gallons per hour. I will do another video on fuel planning, and but yeah, for now, this is how I take my information. Okay. I'll just go here, 2200. I chose 20 degrees above standard temperature. I'm not 20 degrees, I'm 10 degrees above uh, the standard temperature, but I like to go for the worst case scenario, so I always do this. But it's small differences, 1 knot and zero point 0.2 differences in gallons per hour. Okay, I'll always do it like this, go for the worst case scenario. Even if I'm between scenarios, sometimes people just do the I don't know how to say it in English, but it's the medium between the two of them. And I don't. I just go for the worst case scenario. Like this, I'm always comfortable. Now, after your cruise, you'll have a lot of range profiles and endurance profiles where you can also check. I'm not gonna cover this now. I'm gonna cover this maybe in the in the fuel planning video, but not today. So I'm gonna skip this one. I wanna take your attention here to the landing distance. I'll have to, all right, rotate this one. And once again, now it's the same thing, where I'm gonna take these values, okay, which is once again it should be sea level 30 degrees, right? These ones, but once again this is a short field landing, so we'll go one line down, one column to the right. So the school does this. It's worst case scenario again situation. So 535, 1295. And if you come here, so for landing, instead of 535, I have here 562. Why? Because air law tells me that with 1% of upslope or upslope during takeoff and 1% of downslope during landing, I'll have to enhance the distances by 5%. Okay, I'm going to show you later where this is written, but that's why these values I need to do it plus 5% of these values that are here. All right. Once again, we will have here 562, 1000 in the 1359 feet. You once again go for your aerodromes chart. Your what is this? you go for your aerodromes charts, landing distance available. This is in meters. Pass it to feet, all right? Once again, I'm always choosing the worst case scenario. I don't know if I'm going to take off or land from 1.7 or 3.5. I'm just assuming worst case scenario every time because sometimes runways change, you know that. So just always assuming worst case scenario here. And these are my percentages for ground rule. I'm going to take worst case scenario 14% and landing distance with the 50 feet obstacle. I made a mistake here. This is landing distance from a 50 feet obstacle until you're fully stopped. So from 50 feet above the runway until you're fully stopped, okay, 1,359 feet, which is 34% of the runway that you basically have available for you, okay? And this is the main thing that you'll have to present during your briefing. Now, you have to also check some other things with the air law, okay? So cap 698, which is basically the airplane performance manual, okay, still from CAA, and you'll just have to, oh sorry guys, go here for, because you have single engine piston, you have multi-engine piston, medium range jet. So basically we want for single engine piston, we'll go straight to it, and you have some specifications here. So first of all, they just do some, yeah, this is what I want. So takeoff requirements, field length requirements, when no stopway or clearway is available. So we have both, we have stopway and clearway, so this is not for us. When a stopway and or clearway is available, the takeoff distance must, of course, not exceed takeoff runway available, and we already saw that here, right? And then they tell us when multiplied by 1.3, we are talking about takeoff runway available. So I did it here, cap 698 requirements. Takeoff runway available when multiplied by 1.3. So this is it. Takeoff runway available multiplied by 1.3. It's this value must not exceed accelerate stop distance available, which is this value. Okay, so this value, it's lower than this value. Okay, that's what they want us to check. Now, your takeoff distance required multiplied by 1.15. This is the calculation here, which gives this value. Cannot exceed takeoff distance available, which is this value. So this value has to be lower than this one. Okay, we are also good on this one. And when you go for landing here, so do you also have some factorization here? So if you're going to land in grass, you need to multiply by these factors, and if it's wet, it's worse. Yeah, so you can take a look at these afterwards. But there's nothing here for us now. I'm just going to skip it to the landing part and route landing. So let's go for it. So for landing, the landing distance from a screen height of 50 feet, which is this one here, okay? Sorry, landing distance from 50 feet, okay? It's not obstacle, so ignore this, all right, my mistake. Must not exceed 70% of the landing distance available. So I did the math here. This is the landing distance available plus 0.7, which is 70%, which gives you 2,778 feet, and these values, so landing distance required shall not exceed this value, which is landing distance available, 70% of landing distance available. So this has to be lower than this, so we're also good for it. Then they add, if the landing surface is grass, not our case. If the METAR or TAF or combination of both indicate that the runway is wet, okay, you'll need to multiply your landing distance by a factor of 1.15. So just you need to add up 15% of your landing distance required, which is not our case. Okay, tomorrow it's not gonna rain. Basically that's it. So guys, just to resume, first of all, to do the performance calculations, to go to the graphs, you just need to discover what's your pressure altitude. First of all, I hope I made myself clear in relation to that. And afterwards, you'll just need to check if you can take off from the runways that you have to take off. You'll need to check your cruise performance. You'll need to check if you can land at the runway that you want to land, of course, in the alternates. And afterwards, you need to check if you're coping with the air law requirements. All right, this is really, really simple. And well, I think that's it. I truly hope that you enjoyed the video and the explanation, and that you understood everything. Next video, I'm going to talk about mass and balance, I think. And well, that's it. I will see you either in the next video or in class. So, bye bye. Cheers.